All right, in this video lesson, we're going to be talking all about the different algebraic methods that you can use to solve systems of equations. If you recall in the previous section, we talked about how to use graphing to solve linear systems. Today we're adding two new methods, which are called substitution and elimination. So in order to solve by substitution, there has to be at least one equation where the variable is by itself, either y equals or x equals. Once you have that, you then substitute the expression that you know for the solved variable in the other equation. Then you'll solve for whatever variable is remaining, and then make sure to use both the x and y values, because remember, the solution to your system is still going to be a point. So just because we're not doing it by graphing doesn't mean that the type of answer that we get is going to change. So let's take a look at some examples of this. On example number 1, we've got two equations. We've got 2x plus 3y equals 5 and x equals -2. So notice that the second equation is of the form that we need in order to use substitution. Because we know that x is equal to -2, that means that we can take -2 and substitute it for x in our first equation. So that first equation will now become 2 multiplied by -2 plus 3y equals 5. And then simplifying, we'll get -4 plus 3y equals 5. And now we'll just continue to solve our equation. So add 4 to each side, 3y equals 9, divide each side by 3, and we get that y is equal to 3. So our solution then, because remember our solution has to be written as a point, we already knew that x was -2. We now know that y is +3. So our solution to our system is -2, 3. Let's take a look at another example of this. So in number 2, we've got that y is equal to 3x plus 1, and the second equation is 3x plus 2y equals 24. So once again, our first equation is of the form y equals, which is good. What that means is we're going to take this expression, 3x plus 1, and we're going to substitute that in for y. Because y was equal to 3x plus 1, we're going to plug that in for y in our second equation. So that equation will look like this: 5x plus 2 multiplied by y, so 2 multiplied by 3x plus 1 is equal to 24. And now we just have to solve this equation. So probably distribute the 2. That would be 6x plus 2. Copy the rest down. Now let's simplify like terms. So 11x plus 2 equals 24. And now we just solve for x like we normally would. So subtract 2 from each side. And then to get x by itself, divide each side by 11. We're going to come up with x being equal to 2. Now, as we go to write our point, we know that x is 2. We still do not know what our y value is, though. So we need to use x equals 2 in one of our equations, just like we did on number 1. That usually works best if you use the equation where y was by itself. Because we know that y was equal to 3x plus 1. We now know that x is 2. So 3 multiplied by 2 plus 1. Because then you just have to simplify to get 6 plus 1, and it looks like y is going to be equal to 7. So our solution to this system would be the point 2, 7. All right. So on number 3, we're going to do the same kind of thing. In fact, it's set up very similarly because you've got y equals for your first equation. We can directly take x minus 19 and put it in for y in the second equation. So what that'll look like, 2x minus, in parentheses, x minus 19 is equal to 27. It's very important to make sure that anytime you put an expression in for a variable that you're using parentheses, especially in this case because of the subtraction sign, because we'll need to remember to distribute that subtraction sign to both of those terms inside the parentheses. So a minus x and then minus a -19 would become plus 19. Now we can start to simplify. 2x minus x is 1x, plus 19 equals 27. And then to get x by itself, just subtract 19 from each side, and you'll get that x is equal to 8. So once again, we know our x variable. We do not know our y variable yet, but let's go ahead and use this first equation once again. We know that y is equal to x minus 19. now know that x is equal to 8. So we can say that y is equal to 8 minus 19, which 8 minus 19 is negative 11. So our solution to our system is 8 comma negative 11. All right, one more example of substitution, and then we'll take a look at elimination. So number 4, we've got our two equations, y minus x is equal to negative 1, and 2x plus 3y is equal to 2. Notice that this one is different because we do not have a variable that's been solved for yet. So we need to solve for a variable in one of our two equations. Probably would be easiest to use our first equation, because in order to get a variable by itself, especially to get y by itself, that should be pretty easy to do. We just have to add x to each side of our equation, and we get a new equation that says that y is equal to positive x minus 1. So what we can do, we can take x minus 1, put that in for y in our second equation. So negative 2x plus 3 multiplied by, in parentheses, x minus 1 is equal to positive 2. Now we can go ahead and distribute the 3. So 3x minus 3. The rest we will copy down. Now we'll go ahead and combine our like terms. So negative 2x plus 3x is 1x minus 3 is equal to 2. And then to get x by itself, just add 3 to each side, and we'll have that x is equal to 5. Now, with that x being equal to 5, we can put that into any of these three equations. Again, probably the easiest is going to be the third equation where y is already by itself, because we know that y is equal to x minus 1. So if x is 5, then y is equal to 5 minus 1, and 5 minus 1 is 4. Okay, let's next take a look at what's called elimination. So for elimination, you first must have equations in standard form. So as a reminder, standard form is where you have both variables on the same side of the equation. So they'll look something like this: ax plus by equals c, where a, b, and c are numbers. We're then going to look for opposite coefficients. We're going to look for where we can eliminate or cancel out one of our variables. Then we'll solve for our remaining variable, and then end up using a little bit of substitution, which is why we had to talk about it first, to solve for the second variable. Okay, so let's take a look at number 5. So on number 5, we've got 3x plus 2y equals 4, and 4x minus 2y equals negative 18. Notice that they're both in standard form because they both have x and y on the same side of the equation. So next we're going to look for where we'll have some variables that may cancel out. What we mean by that is if we take 3 plus 4, that's 7, those don't cancel, but 2 plus negative 2 is 0, those do cancel. And so if that's the case, then we actually get to go straight to this step where we add the two equations together. So we'll take 3 plus 4 is 7x, 2y plus negative 2y actually add to be 0. They are canceled or eliminated, hence the name elimination, is equal to, and then we'll take 4 plus negative 18 is negative 14. So to solve for x, we just have to then divide by 7, and we've already got our variable for x, which was equal to negative 2. Now, to get the y variable, we need to take negative 2 and put it back into one of our two equations. Notice that both equations don't have y solved for, so it really doesn't matter which equation you choose to use. I'll just choose this first equation because everything is positive. So that was 3x plus 2y equals 4. We now know that x is negative 2, so that's 3 multiplied by negative 2 plus 2y equals 4, which we can simplify to be negative 6 plus 2y equals 4. And now we'll just solve it like we would normally. So add over the 6 and get that 2y equals 10, and then divide each side by 2 to come up with y is equal to 5. All right, let's take another look at this. So number 6, same idea. You've got variables both on the same side. In fact, you've already got variables that'll cancel. Notice that 3x plus negative 3x is 0. So then negative 18 plus 5 is negative 13y and negative 3 minus 10 is negative 13. So to get y by itself, divide each side by negative 13, and you'll come up with y is equal to 1. All right. Now again, doesn't matter which equation you choose to put that into. I'll just choose the second equation, again, just because there's more positive numbers in it, but it doesn't really matter. So 3x plus 5y is equal to negative 10. We now know that y is positive 1, so we'll put that in for y. So that becomes 3x plus 5 equals negative 10, and then we'll solve like normal. So we'll subtract 5 from each side, 3x equals negative 15, and then divide each side by 3, and we'll come up with x is equal to negative 5. All right, now elimination is not always that easy. And what we're about to see is where elimination does become just a little bit more difficult. So number 7, we've got negative x plus 3y equals 12, and 6x minus y is equal to negative 21. Here's the problem. If you try to add these two together like we've done on the previous problems, you end up with the equation 5x plus 2y equals negative 9, and you still have both variables, which is a problem because you can't solve for two variables at once. So we need to do something a little bit different. We need to get opposite variables somewhere. We either need to have kind of the opposite of 6, we really need for x to be a negative 6, or opposite of 3y would be negative 3y, so we really need for that 3y to, or that y to be a negative 3y in the second equation. Now it doesn't matter which you choose to kind of change. Let's try to get this x to be a negative 6x in our first equation. Now, in order for that to work, right now it's a negative 1x. What you would need to do is you would need to multiply that by 6 to get negative 6x. So what we're going to do is we're going to take our entire equation on number 1 and multiply it by 6. And so what we get when we do that is we'll end up with negative 6x, which is good, that's what we wanted, plus 18y is equal to positive 72. The second equation we're just going to copy down, so 6x minus y is equal to negative 21. We didn't do anything to change that equation, so we're just going to copy it down. Now, because we have opposite variables, we can go ahead and add those two equations together. That way, negative 6x and 6x will add to be 0. 18 minus 1 is 17y, and 72 minus 21 is 51. Then to get y by itself, just divide each side by 17, and we'll get that y is equal to 3. Now, once again, we need to solve for x. And again, it doesn't matter which equation you choose to use. Let's go ahead and just use this second equation right here, which says that 6x minus y is equal to negative 21. And we now know that y is 3, so 6x minus 3 has to be equal to 21. So let's go ahead and solve for x. We'll add 3 to each side, so 6x equals negative 18. And then get x by itself, divide each side by 6, and we'll get x is equal to negative 3. All right. Number 8 is going to have a similar idea, which is that you don't have any variables that are going to cancel right away. And in fact, this one's even harder because if you notice, there's no way you can make 3 into a 2 or 5 into a 3 and vice versa. So what we need to do is we need to get kind of the equations to have a number that matches up. In other words, if you think about it, let's just pick x. We could have picked y, but we'll just try to get rid of x first. You want to think about what kind of number does 2 and 3 both go into. And hopefully you're thinking about the smallest number, which the smallest number would be 6. So what we want is we want for one to have a positive 6, one to have a negative 6. So to make that work, let's take our first equation and let's make it a positive 6. So let's multiply our first equation by 2. But for our second equation, in order for 2x to be a negative 6, we're going to have to multiply it by negative 3. All right, so now we're going to go ahead and distribute those numbers to everything in those equations. So we'll take 2 multiplied by 3x is 6x. 2 multiplied by 5y is 10y. and 2 multiplied by negative 16 is negative 32. For the second equation, we'll take negative 3 multiplied by 2x is negative 6x, negative 3 multiplied by 3y is negative 9y, and negative 3 multiplied by negative 9 is positive 27. Okay, so now that we've got those opposite coefficients, we've got 6x and negative 6x, we can go ahead and add these two equations together. Our variable for x is going to be eliminated. 10y minus 9y is positive 1y, and negative 32 plus 27 is negative 5. So the nice part is, because we chose to eliminate x, we actually ended up with an equation where y was already by itself. Now again, to get x, we just have to pick an equation and put our variable back in. So let's go and pick this second equation. 2x plus 3y is equal to negative 9. We now know that y is negative 5, so let's put that in for y. All right, so then simplifying 2x and then 3 multiplied by negative 5 is a negative 15. So we'll write that as 2x minus 15 equals negative 9, and then we'll just continue to solve. So add 15 on each side, 2x equals 6, divide each side by 2, and x is equal to 3. All right, so those are kind of our three methods that we're going to use in order to solve systems of equations, whether it be by graphing or elimination or substitution. So now it becomes important to kind of know, when would you use one method over the other? And so let's kind of talk about that. So for graphing, if you think about when graphing is nice, that's when both equations are in slope-intercept form, or when both equations have y by itself. That's when graphing works really well. Whereas substitution works really well when at least one equation has a variable by itself. Whether that's x or whether that's y, it doesn't matter in this case. For graphing, you want for both of them to be y equals. For substitution, you either want one of them to be x equals or one of them to be y equals, but it doesn't matter which variable is by itself. Lastly, for elimination, you want for both equations to be in standard form. So if both equations are in standard form, that's when you want to look to use elimination. Okay, so let's do this. Let's talk about 9, 10, and 11. I'm not going to solve each of these. I'll kind of leave that up to you to do on your own. But if you'd like to check your answers, feel free to ask me about these in class at some point. But for 9, 10, and 11, let's decide what method would work best. For number 9, notice that you have both variables on the left side of the equation, so they are both in standard form. That would be your clue that elimination would probably work best. In fact, notice that if you added these together, negative 3y and 3y are going to be gone right away. Actually, number 10 is also elimination. If you look, both variables are on the same side of the equation. In fact, if you added these together, y and negative y are going to add to be 0 right away. So if you're wondering how to start these, you've already got two that should be pretty easy to start with right there. In fact, I probably need to work on changing some of these because number 11 is also elimination. Now, on number 11, you're going to have to do some work because if you try to add them together right away, nothing's going to cancel. So you're going to have to do something kind of like what we did on numbers 7 and 8, where you're going to have to multiply at least one of the equations by a number, maybe even multiplying both. So let's do this, because we're not solving these. Let's just come up with a couple of examples, maybe one where graphing would work best, and then a second where substitution would work best. So with graphing, we said that it works best if they're both y equals. So setting up a system of equations, you might have like y equals x plus 1, and then a second equation like y equals maybe 2x minus 3. Whereas for substitution, maybe you have one that's already solved for, like x equals y minus 1. And then the second where it doesn't matter how you write it, but maybe 2x minus y equals 3. All right. Let's go ahead and finish this section by looking at a real-world example of where you could use systems of equations to solve for a variable. So the Math Club and Science Club had fundraisers to buy supplies for a hospice. The Math Club spent $135 buying 6 cases of juice and 1 case of bottled water. The Science Club spent $110 buying 4 cases of juice and 2 cases of bottled water. We want to know how much did a case of juice cost and how much did a case of bottled water cost. So for our variables, I'm just going to use J for juice, W for water. Let's first write an equation for the Math Club. So it says the Math Club spent $135. They bought 6 cases of juice, so that's 6J, and 1 case of bottled water, so that's 1W. So 6J plus 1W has to equal what they spent, so it has to equal 135. Let's next write an equation for the Science Club. So the Science Club spent $110. They bought 4 cases of juice and 2 cases of bottled water. So that would be 4J plus 2W must be equal to whatever they spent for their total, which was 110. All right. So in order to solve, notice that both of these are in standard form where the variables are on the same side, so elimination will probably work best. In this case, I would probably try to get rid of W. You've got 2W right here, so you would want 4W in your first equation to be -2. Oops, let me go back to the notes that we were working on. So you would want to multiply that first equation by -2. So then distributing the -2, you're going to end up with -12J minus 2W is equal to -270. Remember, the first equation you'll just copy down because you don't need to change anything there. So now let's go ahead and add our 2 equations together. -12 plus 4 is -8J. The 2W and -2W will add to be 0. And then -270 plus 110 is going to be -160. Now to get J by itself, divide each side by -8, and you'll come up with J being equal to +20. So it looks like a case of juice costs $20. As for the bottled water, again, doesn't matter which equation you choose to work with. Let's go ahead and maybe just use this first equation right here, which said that if you take 6 multiplied by J, which we now know is 20, plus W, you should add up to be 135. Well, 6 multiplied by 20 is 120, plus W is equal to 135. So to solve for W, just subtract 120 from each side, and you'll get 15. In other words, each case of bottled water costs $15. All right, that is it for this section of the notes. In the next section, we'll be talking about what's called linear programming. We'll be talking about how to use these methods of solving equations to solve a little bit more advanced problems with more kind of limitations and constraints. Until then, have a great rest of your day.